Hey class, Miss Anderson here. 4.3 today, we're going to look at some factoring techniques. We'll start by reviewing some of the factoring techniques from Unit 3, and then you'll be able to extend your knowledge on factoring to do some more types of polynomials, higher degree polynomials. So common binomial factors look like this: 8x plus 16. You see something like this, notice that they have an 8 in common, and so you can factor out an 8. And you're left with an x plus 2. Remember, factoring is the reverse of multiplying. So if I multiply this back in, I'd get 8x plus 16, which is what I started with. So standard form, factored form. So that's just a monomial term, which means I can take out one thing. Difference of two squares is when you have two perfect squares and then subtraction in the middle, like this. And it always factors to a plus b and a minus b. In this case, it would be x plus 3 and x minus 3. Because 3 and negative 3 multiply to negative 9, and then in the middle, if you were to multiply it out, it would add to 0. So that's the difference of perfect squares. And then we had the perfect square trinomials that we used when we did completing the square and solving by square root. So these ones were half of 6 is positive 3, and then squared would be 9. So this one factors to x plus 3 times x plus 3. So 3 plus 3 makes the 6, 3 times 3 makes the 9. So that's our perfect square trinomial. And then we had just general trinomials. If we have a leading coefficient of 1, we don't need the box. We just find two numbers that multiply to 6 and add up to 5, which would be 2 and 3. So then we get x times x to get x squared, and then positive 2 times positive 3 to make 6, and they add up to 5 in the middle. So those are our review, and then we can extend that knowledge because especially with the factoring the general quadratic trinomials, the last one that I did, it's going to be very similar to the next problem you're going to look at here when factoring a quartic trinomial. You can apply essentially the same idea. So we have a equals 1 and c equals negative 24. So a times c would be negative 24, and we want it to add up to 5. So factors of negative 24 that add up to 5 would be 8 and negative 3. And so we'll set up our parentheses here. We have a trinomial. We're going to rewrite it as a product of two binomial terms. The main difference is that your first term is x to the fourth. Since it's just a 1x to the fourth, a box is not necessary, but you could use it. If you're looking at the box method, you're looking at your x to the fourth would go here, your negative 24 would go here, similar to how you set it up with the quadratic trinomial, and then you have your 8 and your negative 3, but it would be 8x squared and negative 3x squared because they make 5x squared. So that's the difference. And then to get x to the fourth, we're looking at what do this row have in common is that they both have at least an x squared. Then x squared times x squared, then x squared times 8, and x squared times negative 3. And so these numbers, since we have a leading coefficient of 1 x to the fourth, the numbers in my x square here do end up being my factor numbers. So x squared plus 8 and x squared minus 3. Now, sometimes you can factor these more because it is a quadratic, but unless it's minus a perfect square number like minus 9, like we saw up here, or minus 16, minus 25, then it doesn't typically factor any further because there's nothing that multiplies to 8 and then adds up to 0. There's nothing that multiplies to negative 3 and adds up to 0. So it has to be a perfect square number there. So we're done with that one. Okay, another quartic function. This one is two terms to start with, so it's structured a little differently than our last one. First, you're going to look at a common monomial term. So what can you take out of both an 2x to the fourth and an 18x squared? So if you think about x to the fourth, that means you have 4 x's, and x squared means you have 2. So you can take out 2 x's from each at most. And then both 2 and 18 are divisible by 2. So I would start by taking out a 2x squared, which means in my first factor, just the x squared would be left. So I took out 2 of them out of the 4. And then 18 divided by 2 would be negative 9. And then I took out all the x's. So then that's as far as that goes. And in this one, I can factor more because I have a difference of perfect squares. So I can find two numbers that multiply to negative 9 and add up to 0 in the middle, which would be negative 3 and positive 3. So this binomial term can factor more to x minus 3 and x plus 3. Now that's as far as I can go and we would be done. So this is using techniques that you've already learned in Unit 3 and then applying them with quadratics and applying them to quartic functions. These are new. Sum and difference of perfect cubes. This formula will be given to you on your assessment, and if you needed it ever, it's you can look it up. So it's not necessary to memorize this, but to be able to know how to use it. And so perfect cube numbers and they are worth writing down so that you can recognize them, get used to seeing them. Similar to perfect square numbers, but we're more familiar with perfect square numbers. Perfect cube numbers are 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 4 times 4 is 16. 16 times 4 is 64. I knew that. I just brain fart. 5 cubed is 125. 6 cubed is, oh, is it 216? Let me see. 6 times 6 is 36. And 216. Yep. And then let's see if I can remember 7 cubed. 49. 343. Okay, that's probably as high as I'll go. Maybe 10 cubed just because it's easy at 1,000. But these are the perfect cube numbers. I knew 1 through 5 pretty good, so those are the ones that I'm going to use probably most often and the ones that you'll see most often. And so here we have 64x cubed and 8, so both of those are in our perfect cubes. 64 is 4 cubed and 8 is 2 cubed. And we have subtraction. So we have difference of perfect cubes, and we have an x cubed. Okay, so we can think of this as 4x cubed minus 2 cubed, and now it fits my form as a cubed minus b cubed, where a is 4x and b is 2. So if I have a difference of perfect cubes and I can identify what a and b are, which would be like the cubed roots of your terms, then you can plug it into this formula. And the formula is you take a minus b, and then you do a squared plus ab plus b squared. And so plugging that in with the values for a and b that I found would be 4x minus 2 for 4x minus 2 for a minus b. And then it would be 4x squared plus 4x times 2 for ab plus 2 squared. And then simplifying that, I still have the 4x minus 2. 4 squared, remember that's going to be 4x squared, 4x times 4x, which is going to be 16x squared. 4x times 2 would be 8x, and 2 squared would be 4. And then that's as far as it's going to go. This is not going to factor any further. So you'll see this piece is similar to your perfect square trinomial that you saw up here, except for that in a perfect square trinomial, you have to have two AB factors for it to factor more. And because when we factor a sum or difference of perfect cubes, you only get one AB term in the middle, then this doesn't factor any further. So if it's a cubed minus b cubed, it always factors to a minus b, and then it's a squared plus ab plus b squared. So we'll practice with these formulas more, and I think they'll get really familiar, but you don't have to memorize them. So let's try it one more time. 8 is 2, so 2y cubed would be the first term, so that's going to be my a term, and 27 is 3 cubed. That's going to be my b term, so I'm going to use a is going to be 2y and b is going to be 3. So using my formula, it's a minus b, so it's 2y minus 3, and then it's a squared, so 2y squared plus a times b plus b squared. So you get 2y minus 3. 2y squared again is going to be 2y times 2y, which is going to give you 4y squared. 2y times 3, 6y, plus 3 squared, which is 9. And then that is be your final answer there. So if I was to multiply like we did in the last lesson, this times this back together, it would equal 8y cubed minus 27. So if I multiply this back together, all of my terms would simplify to just this. So remember, factoring is the reverse of multiplying. So we're taking this difference of cubes term and we're writing it as a product of a binomial times a trinomial. And you'll see in the next lesson we do that so that we can find the solutions for our variables. And so we're just practicing the factoring techniques for now, so getting familiar with these formulas. If it is plus in the middle instead of minus, the formula is just slightly different. So it still goes a squared, b squared, but it starts with a plus b, then a squared minus ab plus b squared. So the plus minus plus, where this one is minus plus plus. Otherwise, they are the same. So sum of perfect cubes. So identifying what your a and b are. So 27x cubed, this would be the same as 3x to the third, and 125 is 5 to the third. And so we could say that a is 3x and b is 5, and then we can apply this formula, which starts as this factors to 3x plus 5 and 3x squared minus 3x times 5 plus 5 squared. And then just multiplying that second piece out. So one more time, 3x squared would be 3x times 3x, so 9x squared minus 15x plus 25. I'm going to do one more. Same thing, so 2x cubed would be 8x cubed. And when we see 1, 1 can be written as 1 cubed is 1. So we have to remember 1 is also a perfect cube. So this is sum of perfect cubes again, where a is 2x and b is 1. So a plus b would be 2x plus 1. A squared would be 2x squared, which would be 4x squared, minus ax times 1 would just be, 2x times 1 would just be 2x, and 1 squared would be 1. So that is new, sum and difference of cubes. The formulas are provided, but it does take some practice to get those down. And then our new method again is factor by grouping. We do factor by grouping anytime we have 4 terms. So in all of the factoring examples I've done so far today have been 2 or 3 terms. So 2 or 3 terms. And so if you see a 4-term one, we have to do factor by grouping. And factor by grouping gets its name because you are going to group the first 2 terms and then the sign and the last 2 terms. And then you're going to factor out the greatest common factor from each group. So these two have a 9x squared in common. So we're going to take out a 9x squared from that group, which is going to leave me with just an x plus 2. So if I multiplied 9x squared times x, I'd get 9x cubed. 9x squared times 18, or 2 would give me 18x squared. And then I'm going to take out the greatest common factor of the next group, with my goal being my last parenthesis b and x plus 2. So what do I need to divide negative 4x by to make it equal to an x? I need to divide it by negative 4. So I'm going to take out a negative 4, and then that would leave me with an x plus 2. So if I multiplied a negative 4 back in, I get negative 4x minus 8, like this. Now I have two terms right here and right here because terms are separated by addition or subtraction. And so these two terms have an x plus 2 in common. So I'm going to factor out an x plus 2. And then when I do that, what's left here is a 9x squared and a minus 4. I just wrote that parenthesis. 9x squared and a minus 4. And then a lot of times you're done there, but I noticed that in this one I have two perfect squares, and 9x squared is a perfect square and a 4 is a perfect square. So it's difference of perfect squares. So that particular one will factor more to 3x minus 2 and 3x plus 2. And now that is as far as you can go. So that's factor by grouping. You can actually do factor by grouping by using the box method as well. So that's kind of neat. Let me show you how to do that. So we're going to make a 2 by 2 box because I have 4 terms. And then I'm going to put the terms in order. So just as I see them. So 3x cubed minus 12x squared, 2x minus 8. So highest to lowest exponent. And then similar to when we use the box to factor trinomials, we look at the row and we find the greatest common factor. So here they would both have a 3x squared in common. So we'd put 3x squared here. Then 3x squared times x make 3x cubed. And then 3x squared minus 4 makes negative 12x squared. And x times 2 is 2x. And then we can double check that 2 times negative 4 does give me negative 8. So that is our factor. So then we have x minus 4 is one factor, and 3x squared plus 2 is my other factor. And then this time we have a quadratic binomial, but it's not difference of perfect squares, and so it doesn't factor any further. So that is it. Neat, huh? I really like doing it this way. I'm going to do it again like that. So I'm going to make 4 boxes, a box with 4 squares, and then put my terms here, x cubed minus 5x squared minus 9x plus 45. So I'm just putting these 4 terms in the box in order from highest to lowest. And then you find your first term by looking at your greatest common factor of this row, which would be x squared. Then you find this spot, so x squared times what gives you x cubed, and you just need another x. Then x squared times negative 5 gives me negative 5x squared, and x times negative 9 gives me negative 9x, and then negative 9 and negative 5 make 45, so it is correct. And then I always write my linear monomial or binomial term first, so the one with a single x, but it doesn't matter what order you write them in because multiplication is commutative. But I start with x minus 5 as one factor, and then it would be x squared minus 9 as my other factor. And then this one does factor more since you have a difference of perfect squares. And so x minus 5, and then x plus 3, and x minus 3. So just being familiar with those perfect square patterns so that you recognize that, so you factor it all the way. Okay, for the sake of time, I think I'm going to be done here. But I can certainly go over more with you another time. So I also have this little Dory's just keep factoring picture, just to remind you we can factor polynomials multiple different ways now we have learned. So first and foremost, always look for your greatest common factor, something you can take out, and then factor as a product of binomials. If a equals 1, you can just jump right to this. If a does not equal 1, then use the box method. Those are all the multiplies to AC, adds up to B, that method. And then you have your difference of perfect squares. Those were your a squared minus b squared, a plus b, a minus b. Those are our special products. This one's perfect square trinomial. And then if you have 4 terms, then you can do factor by grouping, which again, we can use a box. And then sometimes after you take out a greatest common factor, then it's not factorable anymore. And that was like the 8x plus 16. The only thing we could do was take out the 8 and then we were done. It doesn't factor anymore. So after the greatest common factor, it's not factorable. And we could have trinomials that are not factorable as well, and different polynomials that sometimes just cannot be factored. But those are like your methods and things to check. Okay, thanks for watching.